Hi friends, today I'm going to talk about nanoscience and technology. What is nanoscience and technology? Nanoscience is the invisible world. We are entering that, which deals with the study of matter at the nanoscale. That is about matters measuring from 1 to 100 nanometers in length. 1 nanometer is 1 billionth of a meter. That is 1 followed by minus 9 zeros. A human hair is about 80,000 to 100,000 nanometers thick. This will just exhibit how small in nature, which is invisible to normal eyesight. Our RBC is about 7 to 8 nanometers long. The smallest blood capillary diameter about 4 to 7 nanometer. Our nerve fiber is 0.2 to 1.5 nanometer diameter. Oxygen is 0.73 nanometer long. Rhinovirus causing common cold has a diameter between 20 to 30 nanometer, and the atom of gold is about 2.88 to 2.92 nm long, and our sperm is about 40 to 50 nanometer in length. Nanotechnology deals with materials at atomic and molecular levels, where they begin to exhibit unique physical, chemical, electrical, and mechanical properties that differ dramatically from their bulk counterparts. This is due to their quantum confinement state. Nanotechnology is the practical application of this nanoscale phenomena to design and fabricate new materials, devices, and systems, manipulating atoms individually, build materials from the bottoms up, which would mean from nanometric level to normal level we design machines. Later, tools such as scanning tunneling microscope, which was developed during 1981, and the atomic force microscope, both these microscopes, they are all indirect vision. Directly, human beings cannot see. This allowed scientists to visualize and manipulate atoms directly. The discovery of fullerene in 1985 and carbon nanotube in 1991 revolutionized the field by revealing extraordinary strength and conductivity at nanoscale level. Why do materials behave differently at nanoscale? Two main factors explain the uniqueness of nanomaterials: quantum effects and surface area to volume ratio. Since the electrons are confined in limited spaces, giving rise to quantum confinement effects. For example, gold nanoparticles appear red or purple rather than metallic yellow at their confinement state. Area to volume ratio. As particles become smaller, the large fraction of atoms lie on the surface. This dramatically increases chemical reactivity. Therefore, they can act as highly efficient catalysts. In short, small size, new physics, and new chemistry. Approaches in nanotechnology. As I earlier said, it's a top-down approach, which would mean breaking down bulk materials into nanoscale structures. Examples: lithography in semiconductor fabrication, building structures by atom or molecule by molecule through chemical synthesis or self-assembly. Nature itself operates in this fashion. For example, proteins, DNA, and cell membranes are nanoscale assemblies. major type of nanomaterials, nanoparticles of metals, oxides and polymers. Carbon nanotubes, graphene, importantly quantum dots, nanowires, dendrimers. Each exhibit distinctive properties, exceptional strength. For instance, carbon nanotubes are stronger than steel by weight, superior electrical conductivity, and tunable optical behavior, enhanced catalytic activity are the hallmark of nanomaterials. Application of nanoscience and nanotechnology. Medicine. Nanomedicine. Targeted drug delivery systems, cancer therapy using nanoparticles, diagnostic imaging with quantum dots from 2 nanometers to 10 nanometers, controlled release medications. Nanotechnology allows drugs to reach specific cells, reducing side effects and improving efficacy. Electronics. Nanotransistors in modern microprocessors, where they could have a few billion transistors in a central processing unit. High density storage devices, for instance, your SD cards and your pen drives, these are all results of nanotechnology. Supercapacitors, flexible electronics, quantum computing components. Energy sector, high energy solar cells, hydrogen storage devices, advanced batteries, because they have nanostructured electrodes. So in the given space, they can have more electrodes on more cells in order to give more output voltage. That is today's modern day cars, which operate on lithium-ion batteries. Nanostructured materials enhance energy conversion and storage efficiency. Storage efficiency. Environmental applications. Water purification membranes, smart textiles, pollution detection nanosensors, catalysts for clean fuel production. Materials engineering. Self-cleaning surfaces, anti-corrosive coatings, light, weight, high strength composites, smart textiles. Future prospects of nanotechnology lies in convergence of nano plus artificial intelligence plus biotechnology. Emerging directions include molecular machines, artificial photosynthesis, precision nanorobotics, smart biomedical implants. Nanoscience is not merely miniaturization. It is re-engineering matters at its most fundamental level. Nanoscience represents humanity's journey into the infinitesimal world, which would also mean that if we control atoms, we control materials. If we control materials, we shape the future by bridging physics, chemistry, biology, and engineering, making it one of the most interdisciplinary and transformative scientific revolutions of the 21st century. I can keep on telling lots of information, but my time limitation restricts me from doing so. Thanks very much.